Fourth graders, today is Wednesday, January 15th, and we are continuing right along to do Module 5, Lesson 10. And today's learning goal is the same as yesterday's, actually. We are using the area model, and we are using division sentences to show how two fractions are equivalent. So we're adding on to what we learned yesterday, okay? But first, let's talk about the problem of the day. We could see that we put 3 of the smaller units into one group. There's 3 in that group, 3 in that group, 3 in this group, and 3 in this group. So that's why we divide by 3 and 3. Do you guys see that? Okay, so be careful. So this entire rectangle represents one whole. This entire rectangle is one whole. At first, the whole was divided into how many equal-sized units? Everyone? 6. And how many were shaded in? 4. So what original fraction is being shown? 4, 6. But then, when I put 2 smaller groups into one group, how many groups are there now? 3 bigger groups, right? And so we can see our new denominator is 3 because we have 3 units now instead of 6 units. Do you guys see that? And how many of those red big units are shaded in? Everyone? 2. 2 of them are shaded in. So our new fraction is 2/3. We can see that 4/6 is equivalent to 2/3. Avani, earlier you asked, there are 3 groups, so why are we dividing by 2? Avani, can you please explain to me how we do 4 divided by 2 in the numerator and 6 divided by 2 in the denominator? Why are we dividing by 2 if there are 3 groups?
We're dividing by 2 because the bigger unit is 3, and then there's 2 shaded in, so there's 1 shaded in for 1/3, and then there's another for the other third.
But why do we know that it's dividing by 2? It's because how many of the smaller units are we putting in one group? 2. That's why. In our problem, let's start by finding out what fraction is represented by this picture. How many total units are there in this fraction? Sanvi?
9.
So what are my units?
9.
My units are ninths. Very good. How many of those ninths are shaded in? Haruto?
6.
6. So what is the original fraction that is being shown by this diagram? Eyelet. 6/9. Great. Now, we could group it many different ways. We could circle this. Could we do that? No, because 2 of them are shaded and 1 is not, right? We want to make sure we only group shaded things together. Now, could I group it like this? All the shaded stuff is together. Could I make equal-sized groups if that is one group? No, so that's not going to work. I could, however, make equal-sized groups like this. Do you guys agree? Use a highlighter to show your equal-sized groups. When I compose the smaller units to make larger-sized units, how many equal-sized units do I have now? Arna? 3. So my denominator then is thirds. How many of those thirds are shaded in? Here's one that's shaded in, right? And here's a second one that's shaded in. So I can now see by composing or renaming the units that 6/9 is equivalent to 2/3. However, we need to show using division how we get from 6/9 to 2/3. We used to have 6 shaded in smaller size units, but I put them into groups. How many smaller size units did I put into a group? Zara? 3. So in the top, I do 6, and I divided them into 2 groups. There were 3 in each group. By the way, is this sharing division or grouping division? Everyone? Grouping. I keep saying how many smaller units are in one group. It's grouping division. We know that there are 3 in one group. That's why we're dividing by 3. Same thing in the denominator. We used to have 9 units, but I put them into groups of 3. So how do I show using division that I put them into groups of 3? I do 9 divided by 3. Let's use what we know about math facts to see if this is actually true. Is 6 divided by 3, does that equal 2?
Yeah.
Great. Does 9 divided by 3 equal 3? So using a picture and using division, we can prove that 6/9 is equivalent or is equal to 2/3. We are composing or putting together smaller size units into larger units to rename it in an equivalent way. Make sense? Good. So this time it's like we're given the answer and we have to draw the pictures to represent it. So go ahead and take some time to copy down. We're starting with 6/18. And I see that I'm doing some division in the middle to end up with 2/6. So the number sentence tells me that 6/18 is equivalent to 2/6. Okay, so we know that we're going to first have to draw 6/18. Now, there are many different ways to draw 6/18. I could split up my tape diagram into 18 sections like that and color in 6 of them. But we're going to be using an area model. The only difference between a tape diagram and an area model is that area models have rows and columns. Tape diagrams just have columns. Okay? Now, we could make 18 lots of different ways. We could do 2 across and 9 down, or we could do 3 across and 6 down, right? Because we are dividing by 3, that tells me that I'm going to want to have how many rows? 3 rows. Okay, so start by making yourself 3 rows. That'll make it easy later to make 1 group of 3, 2 groups of 3. Does that make sense? Okay. So look at the number sentence. That will help you figure out how to set up your tape, area model. Okay, do we have 18ths right now? What do we have right now? Thirds. How do I turn 8/3 into 18ths? I have to draw columns. How many columns do I have to make?
6.
How do you guys know that? Math facts, because 6 times 3 is?
18.
Good. So draw 6. Oops, that's red. 1, 2, 3, 4, 5, 6. Okay, now we want to shade in 6/18. Could I technically, eyes up on the screen for a second, could I show 6/18 like this? 1, 2, 3, 4, 5, 6? Is that 6/18? Yes. Is it a way of drawing 6/18 that makes it easy to group it and compose it to 2/6? No. So think about it. What would be easier? Should I go this way? 6/18? Is that easy to compose? No, not really, right? I mean, we could. We would just go like this. 1, 2, 3, 4, 5, 6, right? But is that the way we've been doing it in class? No. So the easiest way to show 6/18 in a way that we can compose it later is to do 6/18. Go ahead and shade that in your tape diagram. Okay. In this diagram now we show 6/18. Am I missing a line? There we go. Okay. Do you guys agree that that's 6/18? Now, in the math sentence, I'm dividing by 3. That means I'm putting 3 into one group, right? So here, 1, 2, 3 in one group. 1, 2, 3 in one group. 1, 2, 3 in one group, etc. When I do that, if I just look at the red lines, in fact, I could even, if I erased these lines, right? Did I change the amount that's shaded in? Did I change the amount that's shaded in, guys? No. But now, instead of having 18ths, what size units do I have? 6, right? And how many of those 6 are shaded in? 2. Okay, so this is how, you don't need to erase the lines. I just wanted to show you because I could. This is how you show that 6/18 equals 6 divided by 3 all over 18 divided by 3. Where are we doing the dividing by 3? We're dividing by 3, but when we put 3 into one larger group, okay, equals 2/6. Here we have 2 fractions, 6/9 and 12/16. Go ahead and write those 2 fractions in your notebook. Write them on top, right next to each other is fine, but leave a little bit of space. We want to rename these. We want to compose or decompose. Sorry, we want to compose them so that we rename the fraction. Okay, we have to use division. We want to see if we can use the largest common factor between the numerator and the denominator. Okay, so let me show you what I mean. Let's talk about that. What does the word largest mean? It's the biggest. What does common mean? They have something in common. It's the same. What's a factor? What's a factor? Talk at your table groups. A factor is a number that you can multiply with another number to get a multiple, right? So we're going to see if we can find the largest, the biggest, common, same factor, there's no other word that means factor, between 6 and 9. So let's list all of the factors of 6. What are all the factors of 6? 1, 2, 3, and 6. Now let's list all the factors of 9. Ready? Go. 1. What else? 3. What else? 9. Is there anything common between the factors of 6 and the factors of 9? Everyone? 3 is a common factor. That means that 6 can be divided by 3 and 9 can be divided by 3. So we can divide 6/9 by 3 over 3. Would that work? Yes. And would that help us rename the fraction? Let's do it. We can say 6/9 equals 6 divided by 3 over 9 divided by 3, which will equal, what's 6 divided by 3, everyone? 2. What's 9 divided by 3, everyone?
3.
So that means that 6/9 can be renamed as 2/3. And we use the largest common factor between the numerator and the denominator to do that. Does that make sense? When you do this, when you rename a fraction using the largest common factor, that is called simplifying the fraction. We're not changing the value, but we're writing an equivalent fraction using smaller numbers. Let's try it again with the next one. 12/16. Let's first find the greatest common factor. Let's do that by listing all the factors of 12, and then we'll list all the factors of 16. By the way, between 6 and 9, was 1 also a common factor? 1 is always going to be a common factor, but will it most oftentimes be the largest common factor? No, it also oftentimes be the smallest common factor. Okay, what's the smallest factor of 12, everyone?
1.
What about 2?
Yeah.
Okay, what about 3?
Yes.
What about 4?
Yeah.
What about 5?
No.
What about 6?
Yes.
What about 7?
No.
What's the next factor?
12.
Good. Now let's list all the factors of 16. I want you to notice, especially those of us who are a little bit lazy sometimes and don't write things out the way Miss O does, I want you to notice that I'm writing the number over here. I'm not writing it as a fraction. We're not ready for it as a fraction yet. I'm just writing out the number so that I know which factors I'm writing the number for. Anshul, could you please join us? Okay, what are the factors of 16? Where should we start? Everyone?
1.
Okay, next?
2.
Next?
3.
Is 16 divisible by 3?
No.
Okay, next?
4.
Next? 8, right? And then 16. Go ahead and circle all the common factors. 1 is a common factor. 2 is a common factor. What else is a common factor? 4. What is the largest common factor? What is the largest common factor between 12 in the numerator and 16 in the denominator? Everyone?
4.
So that means I can say that 12/16, if I want to use division, what should I divide by?
4.
I should divide by 4?
4 over 4.
4 over 4. Good. I can say that this is equal to 12 divided by 4 over 16 divided by 4. Because I'm trying to look for a version of 1 where the numerator is divisible by that number and the denominator is divisible. And that's how the largest common factor helps us. Good. What's 12 divided by 4? Everyone?
3.
What is 16 divided by 4?
4.
So that means that 12/16 can be renamed or simplified as what equivalent fraction?
3. 4.
Very good.